What's up, everybody? Welcome back. In today's video, we are going to create something like this from end to end. Here, you'll be able to ask a question, and once you ask that question, you'll be able to get an answer from your AI system. And here we can see that the model is thinking, and after the process is completed, now you'll be able to get your response. And not only you will get your response, you will also get some additional details like where that response has been retrieved from. But before all of that, let's have a look at the end-to-end workflow of what we are going to build in this tutorial. Here, for instance, we have a user that is going to send a question to the system, and that system performs a couple of steps. We have here querying an API gateway, and that API gateway is going to trigger a Lambda function, which is going to get data from our OpenSearch knowledge database. And from that knowledge database, we'll also get the response back to the user. But before the user gets all this information, we have an admin who is going to upload data into an S3 bucket. And that S3 bucket is going to be linked into an AWS Bedrock fully managed environment. And from there, we have a semantic chunking that's going to be performed on these data from the S3 bucket. And once we have those data chunked, then we'll be using an AWS Titan. This is actually Titan version 2. We are going to leverage an AWS Titan version 2 to create embeddings of those chunks, which are going to be stored into an AWS OpenSearch vector index. And once we have those data available, finally, users will be able to make those queries. This is what we are going to build from end to end. If you're ready, let's get started. And during the entire process, you need to be logged in as an IAM user. Here, I'm logged in as an IAM user, and I have this is something that I've explained in my first video, which explains in 5 steps how to create a chatbot within AWS Bedrock, which is kind of different from this tutorial. And here in this tutorial, we are building a chatbot outside AWS Bedrock. So, okay, if you haven't seen that first video, I recommend you for watching that video first before following the second one, which is this one. Let's start by creating our S3 bucket. So from S3, we create the bucket S3 by selecting create button, and let's give that bucket a name. Let's say research paper on buckets, and leave everything else by default. So we are going at the bottom, hit create bucket. Oh, research paper buckets, Bedrock, for Bedrock, for Bedrock. The reason why this name was not available is because when creating a bucket, it's globally available. It means that someone else has created that bucket somewhere, and just change it to give a different name and go back and create a bucket. All right, once the bucket is available, here is research paper for Bedrock. We can click that bucket and upload data. Data that I'll be uploading are 3 research papers. Attention is all you need on BERT paper and deep residual learning. Now we can upload these documents and select upload. All 3 documents have been successfully uploaded. Now close this one and get back to the dashboard. The next step is to create a knowledge base from AWS Bedrock. So let's get back to console, and in search bar, here you can see that the Amazon Bedrock service name is already available. This is because I have used it before. Otherwise, you can just type here in the search bar Bedrock, just going to give you access to the service name Amazon Bedrock. And from here, get started. And also make sure that you are in North Virginia, East, which is US East 1 region, because most Bedrock services will be available in that region. Now, below Builder Tools, select Knowledge Base and create Knowledge Base. Let's give that knowledge base, let's say research paper knowledge base. And the data source is S3 because our data is hosted in S3. Now, next. And where we are going to access that data is within this AWS account. And here we chose research paper bedrock research paper, the bucket that we have created, and choose. Now we choose the chunking option. Here we are currently at this level. As an admin for data management, I have uploaded data in S3 bucket, and that S3 data is going to be chunked using the default chunking. And here I change that to default chunking and select next. And for the embedding, we are using Titan text embedding version 2. So we select that. Go next. Before going next, I'm going to use AWS OpenSearch vector store. So I select this one here. Next. Here we have the details of the creation for our vector store. Now we double check that we are happy with everything before selecting create knowledge base, which might take a couple of minutes to create everything. Successfully creating the knowledge base should provide such message saying the knowledge base has been created. And we can see, let's go to data source, should be able to see the name of the knowledge base that we have created. All right, now let's move that here. And after the knowledge base is created, we need to sync that knowledge base with the data from the S3 bucket. So we select the knowledge base and sync. This is going to create the actual vector index within the knowledge base. And here again, we see that the sync process is complete. Perfect. We are currently at this level where we have the vector store created. Now we need to create a Lambda function that is going to interact with that vector store along with the foundation model to interact and get answers from users' question. Now let's go ahead from the console and create that. Let's type lambda right now, create a function. And let's say this function's name is research paper function or research paper chat function. And the runtime is Python 3.12, and default. Let's leave that default execution role. Later on, we'll be attaching additional policies, and let's create that function. Here we can see that the function has been created, and in the code section, here is where we'll be implementing everything. And I have the whole function handy. I have implemented the whole function handy here. And let me paste that here and explain in step by step the whole configuration. Let's zoom in a little bit to make it a little bigger. So first of all, what we're doing, we import some relevant libraries like OS, JSON, and Boto3. We define the knowledge base on details and foundation model to be able to set up the client. First, the client name is Bedrock Agent Runtime. This Bedrock Agent Runtime is going to be used to interact with the API, which is retrieve and generate. Retrieve and generate here is the API that we'll be using from AWS documentation. And once we have that, first we need to provide the knowledge base ID and the foundation model ARN. And that knowledge base ID can be found from the knowledge base that we have created here. Here we have a knowledge base ID. So we copy this. We copy this and get back to the function. As you can see here, os.environ knowledge base ID, this is an environment variable. And to be able to set up environment variable here at the top, configuration section. And in configuration section, let's first get back here. In the configuration section, in environment variable, we edit to be able to add a new environment variable. And the name is, all right, we have knowledge base ID and we set that here. And the value is the one that we copied on the paste here. And also we have another environment variable, which is the foundation model ARN. The foundation model ARN can be found in here, base model sections. And we mentioned that in here we'll be using cloud foundation model, and we have different models from clouds. So let's choose cloud 2. We are going to take the cloud 2 foundation model. And in here we have different models that we can choose from. And here is the one that we'll be using. And we copy that. Once we have copied that, then we paste that the value of the environment variable called foundation model, FMARN. And once we have all that set up, we can save. After the environment variables are configured, now we define the actual Lambda function here. So that Lambda function is taking users' inputs, users' query. That's what we have seen here. Users provides the query here, that inputs given by the user. And once we have that query, then we perform one single API call. That single API call is going to use that query, which is given here input text. The value is user's query. And it's using the retrieve and generate configuration. And type is knowledge base because data is being triggered from the knowledge base. And here we give the knowledge base ID that we have here and the model, the foundation model that we have set up here as well. And once we run that retrieve and generate configuration, and once we have this one, and using the retrieve and generate function, we are going to get response, and that response contains some additional information, actually valuable information. And here we are retrieving those details like citation, reference, and final response. Let's get those details. The citation here, we getting all the citations, and from the citation we will get the reference. The reference is the details that will be providing information about the S3 locations containing the actual documents with where information has been extracted from. And here we have the S3 location that we get from the S3 location here. So let's get back to the documentation. We'll see that S3 location here we have the S3 location key, and from that key we get the URI, and that URI is what we are getting here. So we get the path to the S3 getting containing the information. And generated response is the response generated by the model. This is the actual response here. And that response can be also from the output section of the documentation. It's the one below here. Should get that from the output here all the way down. The output here. That output, we get the text section from the output of the model. And once we have all these details, now we create the final result as a JSON. The final result is code status 200, saying that everything is successful. The query, we want to get the user's initial query along with the generated response and the source where the response has been extracted from. And we try to print things here and return the final result. All right. This is a long process, and also when doing this kind of back and forth with the model, sending the question It might take a couple of seconds. And if you get into the default configuration of Lambda, this is only 3 seconds, meaning that the Lambda take 3 seconds to perform all the tasks and then timeout. We don't want that 3 second because it's not enough. So what we can do is to change that 3 second to, let's say, 1 minute. The timeout is 1 minute, which is enough, I believe, to be able to make those calls end to end. And from the function, we can see that that function needs to be able to interact with AWS Bedrock. And for that, we need to give it access to AWS Bedrock via execution roles. And to do that, let's come back to configuration. And from configuration section, permission. And here is a role that needs to have additional policies to be able to interact with AWS Bedrock. And here we add permission, attach policy. And the policy that we are going to attach is AWS Bedrock. Bedrock. So we give it Bedrock full access. Attach and add permission. Now with this permission attached to the role of the Lambda function, we should be able to interact with AWS Bedrock. Now get back to the code. Now deploy. Perfect. This code has been deployed. Let's create a test, config test. And let's say research um, paper, research paper test chat log tests. Okay. A private. Now we need to give the JSON event. Here we have user requests, user query, I believe. In that user query, let me take the same question that I had here and give it to the model. We have now save. Okay, we can finally test. This is going to run the process of testing the model. Here's the response that we got from the Lambda function. The query is the question that we asked. The generated response is given here. Here we have the generated response. And as well, we have the S3 location. That S3 location is where, the document containing the response from that question. Perfect. We can see that the function is working. Now, the next step is to plug that function into an API gateway so that users using an interface externally can interact with that Lambda function. Now to create an API gateway, we can type API gateway in the search bar, create API, and here we have REST API. So build the REST API. And from that REST API, let's say research paper REST API. Research paper chat. Let's give it chat REST API. And endpoint is regional. Endpoint type is regional here. And create an API. Once the API is created, we need to create a new resource. The resource is basically the route to access that API. Let's say chat API, Bedrock, chat API, API resource. All right. And we create the resource. And each resource has a method associated to that resource. So we create a method. And here the method is post because we're going to post data to the Lambda function that we have created. And here we should be able to see all the Lambda functions that we have created. If you don't see the Lambda function that we have created here, you can just come in the Lambda function section and copy that ARN. Copy the ARN of a Lambda function and paste it here. You should be able to see it. So this is the Lambda function that we are going to trigger and create the function. Perfect. Close these green things. Okay, and once that Lambda function is created, the next step, let's give this, we can test the API gateway. Once the API gateway is created, we can test it here. And from testing, we give the same body here that we got from the, let's copy the same JSON data here and paste it. But we only need the query. We only need a query. So here we remove all of these and keep the query and test. All right, we see that latency error, key error, lambda. Let's see what is, oh, not query, actually, it's not query, but it's user query. This is user query. Now test it again. Perfect. So we can see that the execution of the function is successful. We get pretty much the same details as the one that we got from the execution of the Lambda function. This means that our API gateway is working perfectly. To be able to use that externally, we need to deploy the API and choose an option new stage. Let's give that stage a name, dev, and deploy. And once the API gateway is deployed, we should be able to access an invoke link, and we can copy that invoke link and perform some testing using tools like Postman. And in Postman, we can create a new collection, and within that new collection, REST APIs here, and we're doing a post request. And within that post request, we just paste the invoke URL that I had here in body. Within that body, let's copy the exact same details that we had here. Let me copy this and get back to Postman. And within Postman, we're going to paste this. Once again, don't forget to provide the correct key, which is user query and not query. User query and send. We send this here. So via Postman, we are querying our API gateway, and here we get the same details. As you can see, everything is working. The API gateway is working. We are able to interact with the API gateway from Postman. And instead of doing via Postman, we are now going to perform the same task by building our graphical interface. Here is the implementation that I have set up, and all the code is in a step by step. First, we load the Lottie file. That Lottie file is going to be able to show the brain animation, showing that the model is thinking. And here is the call API call function. And this is where you put your API gateway link. And that link is the same that we have here. We have used in Postman. And we copy that our link, paste in that section. And once we have that, it's going to perform like the relevant processing to be able to interact with API gateway to retrieve details from the knowledge base according to the architecture. And here is the actual Streamlit app. In the Streamlit app, we have a page title, which is Research Paper AI Assistant with the page icon. I'm putting that little brain here. And the title is Research Paper AI Assistant. And user question is where user is going to provide a question. And here we have a get answer. The get answer button, once clicked, is going uh, to spin up the process of calling the API and also removing all the spin brains, and here we get the result. The result is going to return, first we have the response that is going to be provided here. The response is going to be provided, and here we have C details expander, where user is going to be able to see the initial query that has been provided, the status code, and the source, which is the S3 location that we retrieved from the API call. Once we have all these, now we can run the S3 Streamlit app. Let's say Streamlit run app. This is going to open a new browser, a new window. Here, our Streamlit application. And once we have that opened, here is a little brain that I had in the code. And let's ask a question. This is one of the questions that, the same question that I was asking. And get answer. Once we hit get answer, it's going to spin up the whole process and start thinking. This is where the Lotte thing here is. Looks cool. That's why I think it might be interesting to put it here. And here is the response. Along with the response, we have the initial query provided by the user and also source, the source document, which is attention is all you need. So this question is it's relevant to these documents. And once we have that, it might be interesting to ask other questions. I had this second question. What is the main idea behind BERT's pre-training approach? Get answer. So we asking a different question to the model to know more about BERT's pre-trained approach. And here we see that the main idea behind BERT pre-trained approach is to pre-train the model or unlabeled data over, and here we have all the details. And clicking on detail, we can see that the initial question is here, the code status code is here, and the document source, this time we can see that this has been retrieved from BERT pre-trained deep learning model. So depending on the question and where the answer is from, we are pointing exactly into the document containing that response. Perfect. Now, instead of building your chatbot within AWS console, now you are able to create your end-to-end chatbot using all the necessary services: AWS Bedrock, Lambda function, API gateway, and also you can integrate that interface into any API environment. Since the final result is available as an API, you can integrate that to any services out there. And after all of this, a very important step to not forget is to clean up your working environment. So let's get back to Amazon Bedrock. We are first going to remove the knowledge base that we have created. So get back to the knowledge base section. Knowledge base, select the knowledge base. Once we have selected the knowledge base, we delete the knowledge base. So type delete to delete the knowledge base. Once the knowledge base is deleted, now we also need to delete the OpenSearch index. So type OpenSearch, Amazon OpenSearch. And within serverless dashboards, now we can see that the collection is available. Now we select that collection and delete the collection as well. Confirm. Deleting. This is deleting. And this way we are not going to be charged for letting things run. If you like this video, give it a thumbs up. Feel free to share, and also let me know in the comment section what you would like me to cover in my future videos. Thank you for watching, and thank you. Bye bye.